Our objective in this lesson is to analyze the effects of changing the values of a, h, and k in the equation y is equal to a times the quantity x minus h squared plus k of a quadratic function on its graph. Let's have a quick review of our previous lesson featuring parabola. Given f of x is equal to x squared plus 4x minus 2, we are going to determine the following. First, we have to determine the value of our a, b, and c. Our a is the numerical coefficient of x squared, so that is the invisible 1. Our b is 4, and our c is negative 2. Next, we're going to recall the formula for h. Let us substitute the value of b here and a here. Negative 4, 2 times 1 is 2, negative 4 over 2. And this will give us negative 2. Next, let us recall the formula for k and let us substitute our values here. 4 times 1 is 4 times negative 2 is negative 8. 4 squared is 16. 4 times 1 is 4. Negative 8 minus 16 will give us negative 24. Negative 24 divided by 4 is negative 6. So we now have our vertex, negative 2, negative 6. The opening of the parabola is upward. Why? Because our A here is positive. And since it is opening upward, then we have a minimum point. And the axis of symmetry is equal to the h. X is equal to negative 2. Our domain would be the set of all real numbers, and our range will start from our k, negative 6, to positive infinity. Let us check our answer by looking at the graph of this function, and we have it here. So correct, our vertex is located at negative 2, negative 6. Opens upward, thus it has a minimum point. This is the axis of symmetry. Our domain is from negative infinity to positive infinity, while the range starts at negative 6 going to positive infinity. Now let us discuss vertex at the origin. We have learned previously that the vertex form of a quadratic function is written in this way. What if our a is equal to 1, our h is 0, and our k is also 0? Let us substitute these values here. So we have x minus 0 is x, quantity squared is x squared, times 1 is still x squared. No need to write plus 0 here. So we have y is equal to x squared. This is the function of the parabola whose vertex is at 0, 0. In order to graph this, let us have our table of values. I already assigned values of x. Now let us compute for the value of y. Let us substitute negative 2 here. Negative 2 is squared will give us positive 4. Negative 1 is squared will give us positive 1. 0 is squared is 0. 1 is squared is 1. And 2 is squared is 4. Let us graph this. We have negative 2, 4. Negative 2, positive 4. Then we have here negative 1, 1. Negative 1, positive 1. 0, 0 is at the origin. Then we have 1, 1, 1, 1. And the last one, we have 2 for x, and y is 4. Now let us connect the dots. This is the graph of our mother function y is equal to x squared. All transformation of graphs that we will discuss later will be derived from this graph. Now let us study the effect of negative a. Once again, let us recall the equation of a parabola whose vertex is at 0, 0. Let us recall also the graph of it. This is the vertex, 0, 0. Now, what if we have a negative a? Let us say negative 1. So this will become y is equal to negative x squared. In here, the value of our a is negative 1. What do you think will the graph of y equals negative x squared look like? To graph it, we are going to determine some key points from our mother graph. This is the origin. This is 0, 0. This one is 0.11. And this one is 0.24. Now we are going to use these points to be able to graph y is equal to negative x squared. All we have to do is to look for the y-coordinate of these key points and then multiply it by negative 1. So 0 times negative 1 is still 0. So the point is still at 0, 0, meaning the graph of this function will still pass through 0, 0. The next point is 1, 1. 1 multiplied by negative 1 will give us negative 1. So the new graph will pass through 1, negative 1. Let us plot 1, negative 1. Our next point is 2, 4. Let us multiply 4 with negative 1, and that will become negative 4. So the point is 2, negative 4. Let us plot this. We have 2, negative 4. Now let us locate the counterpart of these points on this side. So this will be at negative 2, negative 4. This one will be at negative 1, negative 1. Now let us connect the points. So this is the graph of y equals negative x squared. What did you notice? The original parabola reflects down. And now our parabola opens downward. Now let us determine the effect of a when a is greater than 1. Again, let us recall the function of the parabola at vertex 0, 0. We're still going to use these key points here. Let us say our a is greater than 1. For instance, we have y is equal to 2x squared. This is our a, 2, and it is greater than 1. We're going to make use of the same process we did earlier. Let's have 0, 0. This time we are going to multiply 0 with 2. And 0 times 2 is still 0. So the new graph will still pass through at 0, 0. And that is at the origin. Our next point is 1, 1. 1 times 2 is 2. So meaning the new graph will pass through 1, 2. Let us plot that 1, 2. Our next point is 2, 4. 4 times 2 is equal to 8. So the new graph will pass through 2, 8. Let us plot that. We have 2 and this is 8. Now let us determine the corresponding points on this side. This will be at negative 2, 8. And this one will be at negative 1, 2. Now let us connect the points. Here is now the graph of y equals 2x squared. Now what did you notice from our original graph to our new graph? The parabola becomes narrower. That is the effect when we multiply our mother function with a greater than 1. This time, let us have an a which is less than 1 but greater than 0. Let us say our a is 1 half. So still, we are going to make use of the same method. Let us have 0, 0. Let us multiply 0 with 1 half, and that is still 0. So the new graph will pass through 0, 0, and that is at the origin. The next point is 1, 1. Let us multiply 1 by 1 half, and that is 1 half. So the graph of this will pass through 1, 1 half. This is 1, and somewhere here is 1 half. Our next key point is 2, 4. Let us multiply 4 with 1 half, and that will give us 2. So the graph of this will pass through 2, 2. That would be 2, 2 here. Now let us determine the corresponding points on this side. This will be at negative 2, 2, and this will be at negative 1, 1 half. Now let us connect the points. So what did you notice this time? From our mother graph to our new graph, what happened? The parabola becomes wider. That is the effect when we multiply x squared with a less than 1 but greater than 0. To give you more examples, let me show you an app where we can graph several functions. All you have to do is to type in your browser Geogebra. This one will appear, and in here we are going to type our function. Let us start with our mother function, y equals x raised to 2. So here is now the graph of our mother function. Exactly the same like what we have before. Now we are going to graph another function. Let us say y is equal to 2x raised to 2. Earlier, we have learned that when we multiply x squared with a greater than 1, our graph becomes narrower. And it is true. Let us try another function. Y equals 4x raised to 2. Again, the graph becomes narrower. As our a here increases, our parabola becomes narrower. Let us try the value of a which is less than 1 but greater than 0. So let me untick this. Let me put another function. Y is equal to 1 half x raised to 2. So we have graphed this earlier. The graph becomes wider because our a here is less than 1 but greater than 0. Let us try another function. Y equals 1/4 x squared. So you will notice that the parabola again becomes wider. Again, the green graph is our mother function. And when we multiply our mother function with a less than 1 but greater than 0, such as 1 half, the parabola becomes wider. When we create another function, 1/4, the parabola becomes even wider. Earlier, I also teach you the effect of having a negative a. So let us say I am going to duplicate this, but I am going to make it negative. See what happened to the graph? It reflects down. Now our parabola opens downward. Now let us try with our a greater than 1. I'm going to take this. So the blue one is the y equals to x squared. I'm going to duplicate this input, but this time I'm going to make it negative. So the blue graph reflects down. Our parabola now opens downward. Let us continue with some more transformations. This time, let us study the effect when we have minus h here. So once again, here is our mother graph with the mother function. But what if we have y is equal to x minus 3 quantity squared? First, we are going to solve the value of our x here. X minus 3 is equal to 0. Moving negative 3 on this side, x equals positive 3. Now let us make use again of our key points. We have 0, 0. But this time, we are going to focus our attention with the x coordinate. We are going to add the value of our x here to our x coordinate. So 0 plus 3 is 3. So the graph of this function will pass through 3, 0. Let us plot this. 3, 0. Now let's have our next point. 1 plus 3 is 4. So the new graph will pass through 4, 1. 4, 1. Next point, we have 2, 4. 2 plus 3 is 5. So the new graph will pass through 5, 4. Let us plot that. 5, 4. We have remaining points here. Let us use them. Negative 1 plus 3 is 2. So the graph will pass through 2, 1. This is 2. Here is 1. And the last point, we have negative 2, 4. Negative 2 plus 3 is positive 1. So the new graph will pass through 1, 4. Let us plot that. 1, 4. Let us connect the dots. Here is the graph of y equals quantity x minus 3 is squared. Now, what did you notice with our mother graph? It seems that the new graph simply moved to the right. Let us see if that is correct. Yes, it is. It moved to the right by how many units? By the value of our x here. So the effect of having negative h here, the parabola will move to the right. By how many units? In this case, in our example, it moved 3 units to the right. Let's have another one. What if we have plus h? Let us say we have y is equal to quantity x plus 2 is squared. Same process, we're going to solve for the value of x here. X plus 2 equals 0. Moving this on this side, x equals negative 2. So what do you think will be the effect of having plus h here? Your guess is right. This time, the parabola will move to the left. By how many units? By 2 units. So now let us move our parabola going to the left by 2 units. There you have it. This is the parabola of y equals quantity x plus 2 is squared. To give you more examples, let us go back to our GeoGebra. Let us continue graphing. Let me untick this so that we will only have our mother function. Now let us graph another function. Let's say we have y is equal to the quantity x minus 4 raised to 2. Notice what happened? Our mother function actually moved 4 units to the right. Why? Because we have here negative 4. Let's try another one. Let me duplicate this, but this time I am going to make it plus. So here is now the graph. Our original graph move 4 units going to the left. Why? Because we have here plus 4. So once again, when you have minus h here, the graph will move to the right. And when you have plus h here, the graph will move to the left. Let us continue with some more transformations. Now, what if we have x squared plus k? So this time, I added a numerical value here at the end. Let us say we have y is equal to x squared plus 2. So what do you think will happen to our mother graph? Once again, let us make use of our key points here. We have 0, 0. Focus our eyes again on the y value. This time, add 2. 0 plus 2 will give us 2. So the new graph will pass through 0, 2. Let us graph that. 0, 2. Now let us have 1, 1. 1 plus 2 is equal to 3. So the graph of this function will pass through 1, 3. Let us plot that. 1, 3. The next point, we have 2, 4. 4 plus 2 is equal to 6. So the graph of this function will pass through 2, 6. We have 2 and this is 6. Let us determine the corresponding points on this side. This will be at negative 2, 6. And this one will be at negative 1, 3. What do you think will be the movement of our original parabola? It will move 2 units up. Let us do that. There you are. Our parabola moved 2 units up. And that 2 comes from the value that we added here. Now, what if we have negative k? Let us say we have minus 3. So what do you think will happen to the graph? You guessed it right. The parabola will move 3 units down. So let us move our parabola 3 units down. This time, the vertex is at 0, negative 3. Let us see more graphs in GeoGebra. Okay, so let me untick this. Now let us key in another function. Let's say we have y is equal to x squared plus 6. What do you think will happen to our graph? Mom, there is no graph. Actually, there is. We are just going to move our Cartesian plane. Here is the graph of y equals x squared plus 6. So our original parabola moved 6 units up. And again, that came from the value that we added here. Now, what if we have y is equal to x squared minus 4? There. The graph now moved 4 units down. This is the original graph, and it moved 4 units down because we added negative 4 here. Let us do extra challenge. So we have here f of x is equal to negative 2 times the quantity x minus 2 squared minus 3. Here again is our mother graph whose function is y equals x squared. Let us study the different transformations that will happen because of our new function. These two here will make our parabola narrower. So it will narrow by a factor of 2. Let us do that. There you are. And because of minus 2 here, our parabola now will move 2 units to the right. Let's do that. This is the vertex 0, 0. It will move 2 units to the right, so the vertex will be here. That's it. Now, because of minus 3 here, our parabola now will move 3 units down. So from here, 3 units down, 1, 2, 3. Let us move our parabola. There you have it. And because of negative here, our parabola will reflect down. So let us reflect our parabola down. That's it. This is now the graph of f of x equals negative 2 times the quantity x minus 2 squared minus 3. For the summary, here are the things that we discussed in this lesson. Take time to understand this. Now, it is time to check your understanding. Pause this video for more time. Let us answer the following. Number 1, what will be the new function if y equals quantity x minus 1 squared moves 5 units up? Then we will be having plus 5 at the end. Number 2, in y equals a times the quantity x minus h squared plus k, which letter tells us vertical translation? Meaning, which letter from here gives us the translation up or down? That would be letter K. Next one, what must be the value of A in y equals ax squared plus k so that the parabola widens? What must be the value here? The value must be less than 1 but greater than 0. Number 4, the x minus h in y equals a quantity x minus h squared plus k makes the parabola move in what direction? If we have minus h, the parabola moves to the right. And last one, true or false? In y equals a quantity x minus h squared plus k, if a is negative, the parabola opens downward. Is it true? Yes, it is true. Gets? Our next lesson is determining the equation of quadratic function when the given is table of values, graph, and zeros.